So again, you can see the risk building up here. So the wider the spread of the curve, the more risk. This is T-bills. You notice T-bills are basically risk-free, right? So, okay, so here's the average annual returns. So you'll notice here, you're getting larger returns up here, but as I said, the curve is more spread out, so there's a price to pay for larger returns, and that's called what? More risk, right? So you got to take on more risk. So you'll notice how the average annual returns are very small here, but there's no risk. And you saw the returns I was getting when I was showing you my portfolio, but systemic risk kicked in, called the coronavirus, and I got slammed for $500,000. So I'm going to have to live with that for a while. Hopefully it'll come back. Other than that, I'm in the house here, cocooned in, making videos. I'm sure you're all cocooned in too. Okay, so here was here's an equation, another equation now. Another equation, and this is the average annual return. And the average annual return is simply done by looking at the return from each year, okay? Notice this is a little different now. This is a straight average for each year. Year 1, year 2, the return for year T, blah, 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 and so on. And you divide by the number of years, and you end up with this equation here. And this is the equation for the average annual return. And let me, give me 1 minute, and I'll want to just point. So we're on page 334, okay? So all this information we're looking at is on 334 in your book, okay? So you can look at that in your book, and that'll work well for you. And here is the variance now, using realized returns, okay? Now this variance, notice this variance is a little different than the earlier variance I showed you, okay? So this variance, you just take 1 over t minus 1, and we sum each annual return. This is each annual return minus the average here. So let me go back for one moment. Let me just go back for one moment. Okay. So here's the return we calculated. Notice that's R bar. Everyone see that? That's R bar. And this variance, I believe this variance now, we should be able to calculate this in Microsoft Excel. I believe there's a built-in function called variance, and I believe it's this one. And that being the case, if you take the square root of this, you'll get the standard deviation. So this is important right here. So let me highlight that and make that bold. All right, and I'll save that. Okay. So this equation, I got to see if I can bring up Microsoft Excel here. All right, I'm going to pause this for a minute and try to get Excel up, okay? Well, before I do that, let me see if there's some data we can look at. So here's data from Table 2. What are the variance and volatility of the S&P 500's returns for the years 2005 to 2017? Okay, so here they are calculating the variance, okay? Now, you know, during this period, the average annual return was 10%. So again, you just subtract these, 10 from each one, square it, and then add them up, and then divide the whole thing by 1 over t minus 1. Okay? And then you take the square root to get the standard deviation. And let me see if I can highlight this now. I don't know if it's going to let me. No, I don't think so. So I won't do that. So anyway, so you get the variance in this way, and then you get the standard deviation in by just taking the square root of that number. So this number goes in here, and you take the square root. Okay? And as I said, I'm going to try if I can find the data, I'm going to try to use Excel to solve this problem. I got to see what's built into the Excel. Hold on a second. All right, so hello. So I jumped into Microsoft. I'm back. I jumped into Microsoft Excel, and you can see there's a function here called Variance, and you would just put numbers in each one of these from cells, and what does it say? Estimates variance based on a sample, ignores logical values and texts. So you got to fill these with numbers that you would get, and that should give you the variance. Okay, so that's the variance, and people should try it and see if you can get what the book does mathematically. And the other thing I want to do is try to get, I think standard deviation is stand dev. Let's try that. No. How about sdev? How about I type standard deviation? Here we go. Let's click on this one. There's a lot of different functions in here for statistics. And I'll say okay. This estimates the standard deviation based on a sample. So I think you would use this, or you could just take the square root of the variance. And I think they just take the square root of the variance in this case, right? And you just keep filling in numbers here from a table. Okay, again, you should try that and see how it works. If you have any questions, I'll do it for you. Email me and we'll do one online. All right, so you can use Excel probably to calculate these. Okay, so here's the Excel. Here's the standard. Here's this. Actually, if you could take these numbers and just pop them into Excel, and you'll get the, this gives you the average. Here's the average return, right? Here's the average return. And here's the variance. Now, the numbers you would put in the variance in Excel would be this difference, right? So you would have to get this difference and put this into Excel each time in that table. Okay, so you would have to do that, or maybe you can just subtract in each box. Okay, and that'll give you the variance. So you just have 10 numbers and you just add them up just like that. Square it, square each one, and take the sum, and the standard deviation would just be the square root of that. Okay, and this is telling you, you notice how large this is. This is a pretty large standard deviation. The higher the standard deviation, the greater the risk. Okay, so as this number is going up, you have more risk. Okay, so that's an important consideration. The higher the standard deviation, the greater the risk. So here's the standard deviation for the returns we calculated before. So you'll notice the small stocks had a large return, but you'll notice how great the volatility was, right? And you'll notice how for the T-bills, it has very low volatility or standard deviation because the returns were very low. So this goes hand in hand with the returns. The greater the return, the greater the volatility. Okay, so you can basically look at a security's historical average return to estimate its actual expected return. So, however, the average return, again, is just an estimate of the expected return, right? So the standard error, there's a thing called the standard error, and that's a statistical measure of the degree of estimation error. Okay, so this is going to tell you how much error you have. Now it starts really getting very probabilistic here. So this is where we start running into trouble. Okay. So I think I'll pick this up in after I'm about 10 minutes into this. And we'll go into the probability in the next 10-minute session.